The combustion of butane and oxygen makes carbon dioxide and water. Let's complete the reaction table below. The only thing you're given is that you're burning 100 grams of butane. We can assume that there's plenty of oxygen. Let's figure out the molecular weights. That's what that stands for. C4H10 checks in at 58 grams per mole. I'll be using whole numbers throughout for simplicity. 10 for the hydrogens at 1 gram per mole each, 12 for each carbon. Oxygen is 16 grams per mole, so the molecule is 32. Carbon dioxide is 44, and water is 18. How many moles do we have? Well, if 100 grams is a mole, if 58 grams is a mole, and we have 100 grams, that's almost 2 moles, 1.72 moles. Since it reacts with 6.5 times as many, notice that 2 requires 13. We multiply that through, and we require 11.21 moles of oxygen. It will make 4 times as many moles of butane as it starts with in terms of carbon dioxide. That's 6.9, and 5 times as many moles of water. See how 2 will make 10? That's probably the easiest math right there. And then if we're making 11.2 moles at 32 grams per mole, that's getting on towards 400 grams. 358 grams will do it. 6.9 moles, but 44 grams is a mole. That is what, 300-ish? 303 grams. And by the way, that is exactly how many grams of carbon dioxide is produced. And 8.62 moles of water is 155 grams of water. Always double check with the grams to see that mass is conserved. We started with 458 grams and we ended with 458 grams.